Okay, ma? So the next topic which we are studying is current electricity, ma. So first of all, we should define current. What is meant by current? Current means flow of anything is called current. Flow of water is also called current. Are you able to understand? Anything which flows, that nature you can call it as current. So here in current electricity, what we are studying, flow of positive charges is called as current. Are you able to understand, ma? For example, if you take a metallic conductor, okay, ma, what is this one? This is a metal. So in this metal, free electrons will be present, you know. Free electrons will be present. What is meant by free electrons, ma? చెప్పండి, ఇప్పటికే 14 సార్లు చెప్పినాను. ఫ్రీ ఎలక్ట్రాన్స్ మీన్స్ వాట్? Free electrons means what? The electrons which are loosely bound to the atom, they are called as free electrons. This is nucleus, no, ma? So the electrons which are present in the outermost orbital, they are very loosely bound to this particular nucleus, no? So even at room temperature also, okay, ma? So these electrons, which electrons? The electrons which are present in the outermost orbit. These electrons come out of valency work, okay, ma? And be roaming throughout the volume of conductor. Be roaming throughout the volume of conductor. Are you able to understand? So even at room temperature also, they get separated from the atom and they will be roaming throughout the volume of this conductor. So these are called as free electrons. Are you able to understand? Write down. See, ma. So consider this is one free electron, ma, which is present in this particular metal. So this free electron, it will be moving in which direction? Random direction. Clear, ma? So electron is a very small particle, no? So it will try to move in a straight line, but immediately it collides with another atom. Collisions also will take place, no? Total metallic conductor is made up of atoms only, no? Ions only. Okay? So this electron, after traveling up to this much distance, it collides with another atom, and immediately what happens? Its direction will change. So there it will go collision with another atom, and again its direction will change. So again collision will happen, again direction will change. So like this, it will be moving in random motion. Random motion means what? There is no particular direction. Are you able to understand, ma? So therefore what happens? So these free electrons, okay, ma, will have what kind of motion? Will have a random motion. Okay? But what I do is, I will connect a battery to this one. Are you able to understand? See, ma. So I take the same conductor. To this conductor, I connect a battery. Okay? What is meant by a battery, ma? Battery means what? Battery means this is a source of potential difference, no? Source of potential difference. So it provides potential difference in the circuit. Positive terminal of the battery is at a higher potential. Clear, no, ma? This is at higher potential. And what about negative terminal? This is at a lower potential. This is what happens, no? Okay? So positive potential and negative potential. So if I consider here potential to be 0 volts, okay, ma? At the negative side of the battery, if I consider potential to be 0 volts, then here I can consider potential to be V volts if capacity of the battery is V. Are you able to understand? What is meant by V? V means a potential difference only, no? Okay? So therefore if I consider this potential to be 0, this potential should be plus V. So that potential difference is V minus 0, V. Okay, ma? So here if potential is V, same potential will be applied here also, no? Here also there is a potential of V. and here if potential is 0, here also I can say potential is 0. Okay. So therefore conductor also is applied a potential difference of V minus 0, which is equal to V. Are you able to understand? And what is the length of this conductor? Length of this conductor I will call it as L. Okay, ma? So therefore, what is the electric field? Electric field which is developed. Electric field developed is how much, ma? Can you say, anybody? Electric field inside the conductor is how much? Chapandi. Electric field formula? Potential difference divided by length, no? This is the equation of potential electric field, no, ma? E is equals to V by D. Here what is meant by D? Length of this conductor. So therefore inside this conductor, what is the amount of electric field developed? The amount of electric field developed is E is equals to V by L. Okay, and it is in this direction. Why it is in this direction? That already we have studied. So this is positive terminal of the battery, this is negative terminal, and this will be the direction of electric field. Are you able to understand? Okay. So therefore if an electric field develops in this conductor, now can you say what happens? Can you say what happens, ma? If electric field, this is the direction of electric field, then immediately what happens? So electrons, the free electrons, they start moving in opposite direction to the direction of electric field, no, ma? That is what happens, no? So therefore immediately what happens? Immediately, okay, the free electrons are shifted in, okay, ma? This direction of positive charges is considered to be the conventional direction of current. Conventional direction of current. Okay. So can you say what is the meaning of the statement which I have written, ma? See, ma. So the meaning of this statement is that electrons, they start moving in this direction, no? Okay, ma? Electrons, they start moving in this direction. So therefore throughout this external wire, what will flow? Electrons, they start moving in this direction, no, ma? This is the direction of electron flow. Okay. But if electrons are moving in one direction, it also means that positive charges are moving in opposite direction, no? That is the meaning of this one, no, ma? If electrons are moving in one direction, it also means that positive charges, they are moving in opposite direction. And this direction of positive charges is considered to be the conventional direction of current. Okay. So direction of electrons is not considered direction of current. Direction of positive charges is considered to be direction of current. Arthamautundi kada? So electrons are moving in one direction, but actually positive charges are not there. Positive charges ekkada unnai cheppandi? Where are the location of positive charges? Positive charges are present inside the nucleus. They are protons and they can never travel. Are you able to understand? But we say that what is meant by current? Flow of positive charges is considered to be current. But positive charges, are they flowing? No. Then why we call like that? Because negative charges are moving in one direction. That opposite direction of negative charges, we can say positive charges are moving. And that direction is considered to be the direction of current. Conventional direction. Conventional direction means what? From olden days we are considering that direction. Now also we are considering the same direction. That's it. Okay. So therefore, completed now this diagram? So therefore, how can I draw this diagram? Okay, ma? So therefore, if this is the conductor and this is the battery supply which is given, then I can say that electrons, they are traveling in this direction. Okay, ma? What are these? These are the electrons. But positive charges, they are moving in opposite direction. And this is the direction of current. Current direction is considered to be positive direction of current. Are you able to understand? So therefore, how can I measure this current? Measurement of current. Okay. So I can be written as Q by T. What is meant by Q by T? How much amount of charge is flowing per unit time through a cross section. That is called as current. So in differential form I can write, in differential form I can also write I is equals to dq divided by dt. So very small amount of charge flowing in a very small amount of time, that also you can call it as current. Okay, and the same relation I can write like this also. I can write dq is equals to I into dt. I can write like this also. Are you able to understand? And if current is a variable, if current is a constant, no problem, directly we can use these relations. Okay, ma? If current is a variable, if current is a variable, okay, ma? It means the strength of current, it is changing continuously. Then in that condition, how I can write integration of dq is equals to integration of I into dt. So integration and differentiation will get cancelled. So q is equal to integration of I into dt. So I can write like this also. Are you able to understand, ma? And I am integrating with respect to time, no? So I have to write the limits of time only. So t1 to t2. Are you able to understand? So on this particular equation also questions were asked previously. So try to understand it carefully. Are you able to understand what is happening? See, ma, in this condition I can write q is equals to I into t, no? What does it represent? The amount of charge flowing per unit time in an unit time when current is a constant. I is a constant here. So write that also. Current is what? Current is a constant value in this condition. If current is not a constant, then I can write I is equal to dq by dt, or dq is equal to I into dt. And dq means small amount of charge flowing number. If I want total amount of charge, I have to integrate on both sides. That's it. Fine? Right now. So Sima. So each second 10 power 17 electrons flow from right to left across a cross section of a wire attached to two terminals of a battery. Okay, ma? So consider this is a wire, ma. This is right side, no? This is left side. Antenara? Idi right, idi left. Edo outland. So this is right side consider, and consider this is the left side of this wire. So electrons are moving in which direction? My electrons are moving in this direction. This is the direction of electron flow. So if this is the direction of electron flow, then how shall I connect the battery? Battery should be connected like this, no? Are you able to understand me? Because if this is the connection of battery, it means positive charges will flow in this direction. And electrons should travel in opposite direction. Satisfied, no? How we are drawing the circuit? Okay, no? So then what is the strength of current and magnitude of current? Direction of current already we have drawn, no? See, my electrons are moving in this direction, no? Opposite direction should be the direction of positive charges. Current always flows from which direction to which? Positive terminal to negative terminal. This is the direction of current flow. Oh, atlana. Positive, negative. Okay? Now magnitude of current, how can I calculate? I is equals to q by t. Okay? What is q? Total charge. Q can be written as n into E also, no, ma? Divided by t. What is n? Number of electrons which are crossing. And E is the charge of each electron. So therefore number of electrons are how many? 10 power 17. Charge of each electron is how much? 1.6 into 10 power minus 19 coulombs, divided by time taken is 1 second. Okay? So therefore what is the strength of current? 1.6 into 10 power minus 2 amperes. That is the strength of the current, and this is the direction of current. Current will flow from left side to right side. Understood, no? Electrons are moving in one direction. Opposite direction will be the direction of current. That's it. See this question. So in hydrogen atom, electron revolves around the nucleus. Okay, ma? Consider this is a hydrogen atom, and this is the first orbit of hydrogen. Undede oka orbit anukondi, one orbit of hydrogen. So what is the radius of this hydrogen atom? Ma? Radius is equals to 0.51 angstroms. Actually it is 0.53, but he gave 0.51. Ma. So here there is an electron, okay, and this electron is making how many rotations, ma? So 6.8 into 10 power 15 revolutions per second. If you observe this one, what do you understand? This చూస్తే మీకు ఏం అర్థమవుతుంది? What is meant by 6.8 into 10 power 15 revolutions per second? చెప్పండి అయ్యా. ఫ్రీక్వెన్సీ కదా ఇది. దిస్ ఈస్ కాల్డ్ ఫ్రీక్వెన్సీ. Frequency is how much? 6.8 into 10 power 15. What is meant by frequency? Number of revolutions per second is called frequency, no? So 6.8 into 10 power 15 rotations per second. This is the given frequency. Okay? Then what he is asking us to calculate, what is the amount of current produced? Okay, Sima. If electrons are rotating, movement of electrons is nothing but flow of charge, no? So if electron is continuously rotating, it means current is produced. That is the meaning of this one, no? So therefore, how much current is produced, ma? I is equals to Q by T. Okay? Time, is it given? Time it's not, then how can I do? Frequency is given, but time? Frequency is nothing but 1 by time period, no, ma? Clear, no? So therefore, instead of Q by T, I can write a Q into F also, no? 1 by time period is nothing but frequency. Let us take time of 1 second. Time, how much I am taking, ma? 1 second. In 1 second, how many rotations are produced? 6.8 into 10 power 15. So T is called capital T. Capital T means time period in 1 second. Okay? So therefore, Q is nothing but a charge, no? What is the charge of electron? 1.6 into 10 power minus 19 multiplied by frequency is how much? 6.8 into 10 power 15. So do this calculation. That is the amount of current produced in the hydrogen atom. Okay, ma? And the answer is 1.088 into 10 power minus 3. This is the amount of current produced in first orbit of hydrogen. Okay, that's it. So see this question, ma. So charge flowing in a conductor varies with the time as Q is equals to AT minus half BT square plus 1 by 6 CT cube, where A, comma B and C, they are constants. Find the initial current. First question is what I am supposed to calculate, ma? Initial current. Initial current means what? Current at T is equal to 0. This is called as initial current. Current when time is equal to 0. That is when you started observation. What is the current? That is called as initial current. But here a charge is given, no? How can I calculate a current from charge? Differentiation. So I is equals to dq divided by dt. Charge is variable, no? Current is also a variable. Charge is not constant, no? It is varying with respect to time. So therefore current flowing is also, it is not a constant. It is also varying with respect to time. So differentiation of Q will be how much? Differentiation of AT is A. Differentiation of half BT square is how much? Half B into 2T. That's all, no? And the differentiation of 1 by 6 CT cube is how much? 1 by 6 C multiplied by 3T square. Okay? So 2 and 2 gets cancelled. So 3 1s are 3 2s are. So therefore current is how much, ma? A minus BT plus half CT square. Okay, so this is the amount of current which is flowing in the circuit. Now I want initial current. You know, initial current means what? Current at T is equal to 0. Okay, therefore in this condition I is equals to A minus B into 0 plus half C into 0 square. So what is the amount of current? So I value is how much, ma? It is A, that's all. A only, no? So this is the initial amount of current. That is my answer for first question. Understood, no? Next question. What is the second question he is asking? Time at which current reaches maximum value. Okay? So in which condition current reaches maximum value? Can you say how can I do this calculation? Equation of current I have calculated, no? What is the equation of current? I is equals to A minus BT plus half CT square. Clear, no? Now, what is the question? What is the time at which current reaches maximum value? At what time strength of current will be maximum? How can I calculate? ఆల్రెడీ బోర్డు పైన ఒకసారి 2 సార్లు చెప్పినాను ఇది ఎలా చేయాలి. ఓకే, సిమా హియర్ కరెంట్ ఈస్ వ్యారింగ్ విత్ రెస్పెక్ట్ టు వాట్? విత్ రెస్పెక్ట్ టు టైమ్ ఓన్లీ, నో? క్లియర్ నమ్మా? సో ఇఫ్ ఐ డూ ద డిఫరెన్షియేషన్ ఆఫ్ కరెంట్ విత్ రెస్పెక్ట్ టు టైమ్ అండ్ ఈక్వేట్ ఇట్ టు 0, then the value will be either maximum or minimum. He is asking maximum value, no? So it will be maximum only. So what is the meaning of this? I will do di by dt and equate this one to 0. Then at that instant of time my current will be maximum. Is it clear? So therefore do the differentiation. So differentiation of I value is how much? A minus bt plus half ct square. Okay, బోర్డు పైన క్వశ్చన్లు చెప్పేటప్పుడు నీట్గా వింటూ ఉన్నారా మీరు? నాకేం పని లేక చెప్పడం లేదు, నాకు కూడా పని ఉంది, వినాలి కేర్ఫుల్గా. అర్థమవుతుంది కదమ్మా? సో దేర్ ఫోర్ డూ ద డిఫరెన్సియేషన్ ఆఫ్ దిస్ వన్. డిఫరెన్సియేషన్ ఆఫ్ ఏ ఈజ్ ఏ కాన్స్టెంట్ అమ్మా, ఇట్ ఈస్ 0. డిఫరెన్సియేషన్ ఆఫ్ మైనస్ బీటీ మైనస్ బి. డిఫరెన్సియేషన్ ఆఫ్ హాఫ్ సి ఇంటూ 2t. సో 2 and 2 get cancelled. That's all, no? And equate this one to 0. So therefore it is equal to how much? So minus b plus ct is equal to 0. So therefore ct is equal to b. So therefore t is equals to b by c. Okay, ma? So this is the time at which current will become maximum. Are you able to understand, ma, how we are getting this one? So to get any value to be maximum or minimum, so see that value is varying with respect to what? It is varying with respect to time, no? So differentiate that one with respect to time itself and equate it to 0. Then you will get either maximum value or minimum value. And to confirm that it is maximum value only, again what we have to do? Again double differentiate this one. Malli inkosari differentiate cheyali. That is the rules of maxima and minima. Okay, ma? So out of total 45 questions, at least one question may be of this type. So be careful. Okay, right. And what is the next question he is asking, ma? What is the maximum value of current? So when t is equal to b by c, I will get maximum value of current, no? So take t and substitute in current. That is my maximum value of current. Understood, no? So this is the time at which I will get maximum current, no, ma? So take this value and substitute in the same equation. You will get maximum current. Okay. So therefore third question, I max is how much? What is the equation of current? A minus b into, instead of t I will write b by c, okay, ma, plus half c. Again instead of time I will write b square by c square. So this is the maximum value of current. So a minus b square by c, and c and square get cancelled, no, ma, plus half b square by c. So this is the equation for maximum value of current.